This is number 7 on the honors review to the intro force test. I've got, what must the tension in the cable be holding up a 50 kilogram elevator if the elevator has an acceleration of negative 3 meters per second squared? The negative got cut off, so I just want to reiterate that it is negative 3 meters per second squared. The negative is over here. All right, so first of all, I've got an elevator and it has the weight is pulling it down and the tension in the cable is holding it up. I know that my acceleration is negative 3 meters per second squared. Make sure you don't draw it anywhere on the problem. And 500 kilograms, that is its mass. The only way that I know it's its mass and not its weight is because I look at the unit. Kilograms is mass. If it said 200 Newton elevator, that would be its weight. So 500. A 500 kilogram elevator, I know that it's mass. I'm going to do a side step over here to be able to find the weight, so I can go ahead and put it on my free body diagram. And I use the equation FW equals mg. And so I've got FW equals mg, my mass, times 9.8, which is g here on Earth. And I end up with 4,900 newtons, and that's its weight. So I'll put that right here. It's easy to see. I can go ahead and fill that in. I want to have everything on my free body diagram labeled and numbers if at all possible. So I've got my mass and my weight. I'll need my weight because it's a vertical problem. I need my mass because it's accelerating. I have my given acceleration and then my free body diagram. Last thing to do, sum the forces, set it equal to m times a. Sum the forces, I have 2. The tension is up, so it's positive. The weight is down, so that's where that negative comes from. And then on this side of the equation, I still just have m and a. So I have my unknown tension minus 4,900 is equal to my mass times my acceleration. So all I've done is plugged in. This is the tension, this is my weight, that's my mass, that's my acceleration. And I end up just solving the algebra problem from here. Add the 4,900 to both sides. And in order for this to happen, the force tension is to be 3,400 newtons. Which makes sense. 3,400 newtons pulling up, 4,900 pulling down. They are unbalanced. They're unbalanced in the down direction. Unbalanced forces means there is an F net, which means it will accelerate, and it'll be accelerate going down. In this case, negative 3. If it did ask for what is the net force, remember net force is just the name we give to the phrase sum of the forces. And so the net force in this case would be minus 1,500. So if it asks for that.